we are doing 6.4, talking about just simplifying radicals. All right. Now, we're not just doing square roots today. You guys are graduating up to nth roots. So it's not just square roots. We're going bigger. We're going better. We can do cube roots, fourth roots, all sorts of roots besides just square roots. Okay. All right, let's get to it. So first off, let's identify the parts of the radical. So the first thing is the index. All right, so the index of a root is this guy right here. All right, so this index would be considered n. And we talked about the radicand yesterday. Does anybody remember what the radicand is? Put it in the chat or unmute yourself. What would be the radicand in this example? Go ahead and put it in the chat. What is the radicand in this example? What is the radicand? Ooh, did we forget? Good, I got one. Good guess. No on that one. All right, I think we might have forgotten. It's okay. The radicand is what is inside the radical sign. So what's in the house. All right, so put what is in the house in the chat box now. There we go. Yes, yes. Good, good. Yep, there it is. Good. All right, you guys got it. So the radicand is 81. Good job, everybody who put 81. All right, next one. What is the index in this case? It's a little less obvious. So go ahead and put down what you think the index is for the second line. The index, the index. Okay. Good. I got one right answer. Okay. 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 All right. I got two favorite answers right now. Got two favorite answers. It's either 1 or 2. Okay. Now, the correct answer, is anybody really confident in theirs? All right. I will say most of you guys actually put the wrong answer. The right answer is actually 2. Now, I totally understand why you put 1 though, because usually when we have like x with no exponent, that's equal to x to the first power, right? So you're like, oh, when it's nothing there, it means 1. With square roots, it's different. When it's square root, think about it, square root, right? X squared is x to the second. So the square root is actually with the index of 2. All right, so there's like a understood 2 in this index right here. Okay, so that's a little different. All right, now the simplified answer, if I were to take the square root of 81, would be equal to what? Go ahead and put that in the chat. Good, nice, quick answer there. Good, nice. Got 2 right answers. Simplify, 3 right answers. Simplify, square root of 81, 4 right answers. Good. Everyone's got it right so far. 5 right answers. Good. 6 right answers. 7 right answers. 8. Let's see if we can get to 10. 9, 10. Good. Good job, guys. All right, so square root of 81 we get is 9. Okay, this one's a little bit tougher. The fourth root of 81. Okay, the fourth root, the index is, I think you guys know, 4. Okay, what would the simplified answer be in this case? Ooh, this one's tougher. Ooh, I got 2 right answers already. Ooh, good job. All right, good. And I'm actually gonna change this so you guys can only private message me. So that way everybody's giving me just their answer. All right, Good, I got 3 right answers, 4 right answers, 5 right answers, 6 right answers. Good. Person who asked with the question mark, you got it right. Good. Okay, 7, 8. Ooh, good. All right, I got mostly right answers. All right. The answer is 3. The answer is 3. Now, let me explain why. If we were to break down 81, right? You think about like, well, 81, like 9 times 9 is equal to 81. All right. And then we can break down 9 into 3 times 3. Okay, now you can see it. All right, so if I were to break down 81, it would be 9 times 9. And then 9 I can break down to be 3 and 3, both of the 9s, right? So now notice I got 1, 2, 3, 4 3s. So when you guys simplify a radical, think of this index, this guy. He's like a bouncer at a club. I don't know if you guys understand what that means, but he will only let you out if you have this many of the same number. So, right, in this case, the bouncer says you need 4. So I have 1, 2, 3, 4 of the same number. So that's why they can simplify out and get out of the root. All right. So that's what that index does. All right, let me take a pause and see if there's any questions. You can put it in the chat or you can unmute yourself. Okay, keep putting in the chat if you're writing your question. All right, let me go ahead and get into some of these properties. All right, so these are the general concepts we're going to use in our lesson today. Okay, so square root. If a square is equal to b, then a is the square root of b. All right, if a squared is equal to b, then a is the square root of b. And what that means is a is equal to plus or minus rad b. All right, don't forget that plus or minus. All right, now that's the square root. For the nth root, all right, if a to the n is equal to b, then a is the nth root of b. So what that looks like is a is the nth root of b. All right, and n is in that index. All right, now this one kind of trips people up a bit. So focus on this one. All right, principal root. Some numbers have more than one nth root. So for example, the number 36 actually has 2 square roots. It actually has 2. The 2 are 6 and -6. Right? Because if you square 6, you get 36. If you square -6, you also get 36. So 36 actually has 2 square roots. So when there is more than one real root and the index is even, the non-negative root is called the principal root. The non-negative root is called the principal root. So if we were to ask for the principal root of 36, it would just be 6. So whenever you guys see like rad 36, it's actually asking for the principal root, the positive one. And that's why that's just equal to 6 and not equal to -6. Okay? All right, let's try some out. Okay, so here we go. Simplifying radicals with, we're going to focus on even indexes here, even index. Okay, so I'm going to start calling on people, unmute yourself, and let me know what you get, okay? All right, here we go. Let's try number 1, rad 25. All right, let me pull up my random student picker. All right, Jackson, start us off. Rad 25, what do we get?
5.
5, good job. All right, that's it. Boom, done. That's the principal root of 25. Paolo, number 2. What is negative rad 25? What do you think that would be?
-5.
Perfect. Good. That's how you get to the -5. You just put a negative out in front, and then you get the -5. Perfect. Let's go Riley. Riley, what would number 3 be?
+5.
Oh, careful. There is a negative
Oh.
on the bottom there.
Positive or -5.
Perfect. There you go. All right. So plus or minus 5. You got it. All right. Number 4. Let's see if you got this one. Ethan. What do you think? With the negative on the inside, what happens?
You have to take it out so it'll become an imaginary number.
Good. So what do you get?
I5.
Good. And we're going to flip it. So put the number in front.
Okay.
So 5. I. Good job. Nice. Good job remembering that I. Okay. So that is just how you simplify, showing you what happens when like the positives and negatives are like in or out of the root. Okay, let's try some where the index is a little bit higher. So number 5, I have the 4th root of 16. Help me with this one, please. Russell.
Would it be 2?
Good. And how did you get 2?
Because 2 times 2 times 2 times 2 is 16.
Good, yeah. Because if we were to break this down, we get 2 times 2 times 2 times 2. We have a set of 4, and that's what we needed. We have a set of 4 2s. So that's just equal to 2. Beautiful. All right, continuing. Number 6. You guys are going great. Let's try Michael P. Number 6.
We would be doing wouldn't it just be -10?
Perfect. You got it. All right. That's it. -10. Beautiful. All right. Number 7. Let's go Mateo.
±11.
Nice, Mateo. All right. Plus or minus 11. Done. All right. And number 8. Ooh. All right. Let's see. Help me out with this one. Yanni. All right. Yanni, help me with this. What do I need to do to simplify?
So 64 will be 2 and then 32.
Good. Okay, keep breaking down the 32.
And then 32 to 2 and 12. Wait, no.
16.
16, yeah.
Good. Keep going.
And 16 can be divided by so 2 and then 8.
Good. Keep going. Break down the 8.
And then 2 and 4. And then 2 and 2.
And then 2 and 2. Good. All right. So how many 2s do we end up with, Yanni?
6.
Good. 1, 2, 3, 4, 5, 6. So we have 6, and that's what our index tells us we need. So what is this going to be equal to?
So -2.
Perfect. You got it. Nicely done. All right. Oh, I think I see a question in the chat. Could you start with 8 times 8? Yes, you can definitely start with 8 times 8, and then you'll have a more, I guess, even breakdown on both sides, but you can do it this way too. Yeah, you can do 4 times 16. You can do, yeah, however you want to break down 64. Good, nice question. All right, any other questions in the chat? Go ahead and put those in. Sounds like you guys really got it though. So, but definitely keep putting questions in the chat. I love the feedback. Okay. This next part can get tricky. So pay attention to the details, okay? Pay attention to the details. This is where we're gonna need some absolute values. when we have variables like x in the radical. Okay, but there's certain rules about when you need the absolute values and when you don't. Okay, so here, if you notice, square root of x squared is actually absolute value of x. Now, why do we need the absolute value bars? Well, because x can be negative. And remember, this square root is talking about the principal root. We want it to be positive, right? Like square root of 25 was positive 5. So we want whatever comes out to be positive. So that's why we use that absolute value. Okay, so here are the rules. Let me write this in red. All right, so absolute value bars, okay? Absolute value bars are needed when first the index is even. All right, if the index is even, right, like in this index was 2, all right, so it's even. And this is the key right here, the variable's exponent. The variable's exponent goes from even to odd. All right, so when it starts even and ends odd, starts even inside the root, ends up outside the root being an odd exponent, then you need absolute value. So here it started with a 2, so that starts even. And this as an exponent of 1, so it ended odd. So that's why we need absolute value to make sure that is positive. Yes, Angie, go for it. Okay. Now, in this case, number 10, why do we not need absolute value? Right? Well, this one, notice it starts even, but it ended up being even too. So we don't need absolute value for this one. And the main reason why is really because x squared can't be negative. So we don't need absolute value since it's already going to be positive. All right, so let me go ahead and let's do some examples together to kind of get a better grasp of this. When do we need absolute values? Okay. All right, help me with this one, please. Let's see, Timothy, help me out with this one. All right, so number 11, let's do this one together. All right, so let's start with the fourth root of 16.
So that would be like we did with the other problem, that would be 2.
Good. All right, so this, yeah, would be 4, 4, 2, 2. Nice, you saw that you have a set of 2s. So this comes out to just be 2. Good. All right, now what about the a? A to the 4th. If I take the 4th root of a, what would that be?
What did you say?
If I take the 4th root of a to the 4th, right? This is a times a times a times a, right? So when you take out, when you do the 4th root, what comes out?
All the a's?
So it just comes out to be 1.
Oh, 1.
Right? So kind of like with the 2s, this is like a times a times a times a. You have a set of 4. So this comes out to be a.
Oh, okay.
Yeah. But now the question is, it's a variable. So do we need absolute value? Look through the 2 rules here. Is the index even?
Yes.
Yes. Index is 4. So it is even. The starting exponent, is that even?
Yes.
Good. Is the exponent outside, is that odd? Does it go from even to odd?
Yes.
Yes. So what does that mean? We need?
Which one? I forgot the name of it.
So we need absolute values.
Absolute value. Thank you.
Yeah,
didn't-
no
It
problem.
was right in front of me and I didn't even look at it.
It's okay. All right, so we're gonna put absolute values around the A. Okay, try it again. B to the 8th. And by the way, here's a trick. To do the exponents with the variables, you just divide by that index. So 4 divided by 4 got me a to the 1. So b to the 8th, right? Take that exponent, divide by the index. What do we get?
B squared?
Good. Yes, that makes it a lot faster, right?
Yes.
B squared. Do we need absolute value around
No.
B squared? No. Good. Why?
Because it's it's an even.
Good. B squared is even. It went from even exponent to even exponent. So we do not need an exponent there. So this is your final answer. Great job, Timothy. Nice. All right. Okay. Got it, Maddie. Thank you. All right. Let me have you guys keep trying. Let's do this next one. All right. So number 12. Number 12, we got 4th root of parentheses 2x to the 8th. Now, sometimes I think students will want to simplify this, right? And do 2 to the 8th, x to the 8th. I think there's an easier way. Actually do the exponents first, right? Take care of those exponents first. So I would divide the 8 with the 4. And that gets me 2x squared. Okay. I don't need absolute value, right? Because it went from even to even. And so I can just simplify that to be 4x squared. All right, so that's how you would do that one. All right, oh, I just did all of it. Okay, let me have somebody help me with number 13. All right, 13, let's go to Samantha. All right, Samantha, help me with number 13.
Sorry, it's like loading. Okay. Doesn't it just go down to like rad 36? So is that just like 6?
Good. So rad 36 is just 6. Nice. Done. Now, what about the p to the 6th power? What does that become?
Does the p stay the same?
Yeah, so stay with the p. The exponent will change though. So what will the new exponent be?
I don't know.
Okay, that's okay. So what is the index for this root? It doesn't say. So what is the index?
2.
Good. Okay. So just like look at number 12 right next to it. What you're going to do is you're going to divide. So 8 divided by 4, that's how I got this 2 right here. Okay. So divide your exponents. And what do you get?
3.
Perfect. All right. Now, to wrap it up, we have to think, since there's a variable, do I need absolute value? So based off of those rules, is the index even?
Yeah.
Good. The inside, did it start with an even exponent? The p start with an even exponent?
Yeah.
Did it end up being odd?
Yeah.
So what do we need?
Absolute value signs.
Perfect. You got it, Samantha. Nice. So we need absolute value signs around that p. Yay. Good job. Final answer. Final answer. Okay, let's do one more to kind of get a little more used to this. Michael Y, help us out with this one.
Would that be -12 absolute value w v squared?
Nicely done. And yep, that is all you need to do. All right, well done. Questions, type in the chat. And let me just let people have a moment to kind of look through that. Well done, Michael. All right, so we have number 15. All right, so number 15, very similar. So let me go ahead and call on Joanne. All right, Joanne, help me out with this one. Number 15.
I got 4 c to the power of 5 and d to the power of 4.
Good. And do I need absolute value on any of those?
No.
Yes.
Oh,
Index is even. So start by looking inside the radical. Do I have anything that starts even and ends odd? Starts even, ends odd.
c to the power of 10.
Good. Yeah. So that c started even with the 10 exponent, ended up being odd exponent with the 5. So that's why I need absolute value around the c. Okay. Joanne, do I need absolute values around the d?
No,
Good. Why?
because it ended up even.
Good. There you go. So just remember, starts even, ends odd. Starts even, ends odd. All right. Perfect. So just around the c, and that is it. Good. All right. Number 16. Let's go to, let's see, Sebastian. All right, Sebastian, help me out with this one.
Okay, so that's implicitly 2.
Good. All right. Index of 2. Perfect.
Okay. So 3 2.
Yes, Bowen. You can go.
Yeah, it's just, is it just 3b minus 2?
Good. Yeah. And so the 2 dividing by the 2 just gets you 3b minus 2 to the first power, right? Because you
Yeah.
divide. And then the question though is, you have variables. Do you need absolute value?
I don't think so.
Okay, well check, right? Is the index even?
Yes. Oh,
Yes.
yeah.
Do I start with an even exponent?
Yes.
Do I end up with an odd exponent?
No. No. Wait, do I end with an odd exponent?
Yeah, what is the
Yeah,
exponent?
yes.
Okay, so yes, yes, yes. So then yes, you do need absolute value.
Okay.
Okay, so you put absolute value around the entire 3b minus 2. All right, good job, Sebastian. Nice. That was a tricky one. I had it looked a little different. Okay. Oh, I think I got a question in the chat. Oh, yes, bathroom, go for it. Okay. 17. Okay, let's try this one. Let's see, Celine, try this one.
It would be -5, and then there would be absolute value bars around the -5.
Which means that this is equal to
+5.
perfect. Done. All right. So she divided the exponent. All right. Saw this would be -5 to the first power. So she needed the absolute value and simplified it down to 5. Perfect. All right. And let's try the last one real quick. And Leo, can you help me with this one? Number 18. Oh, actually, you know what, Leo, I'm going to save some time because I think we're running out of time. We still have a last section here. Sorry, Leo. I'm going to do this one real quick. I'll save you for the next. Okay. All right. So this one, go ahead and do it on your own, and I will work alongside you. Look up once you're done and check your answer. All right, and that is my final answer. Okay, let's go to our last part here, guys, with odd index. And Leo, I'll have you help me with number 19, okay? All right, so odd index. Now we don't have to worry about absolute values anymore, guys, because it's an odd index. So don't worry about absolute values. Leo, go for it. Number 19.
3.
Oh, good. Okay. Yes, because this is 9, this is 3, this is 3, this is 3. So 1, 2, 3. And the index said you only need 3 of them. So that's equal to 3. Lots of 3s. Okay. Oh, Leo, since that was so short, can you do number 20? What's 20?
-3.
Good. Done. Okay. Great job, Leo. All right. Number 21, a little bit trickier. Put it in the chat. What do you think number 21's answer should be? Put it in the chat. Okay. 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 Ooh, okay. I'm getting 2 favorite answers right now. Let's see which one is correct. I have 2 favorite answers so far. I got 3i or -3. Those are the 2 favorite answers right now, 3i or -3. So here is what I want you guys to notice. The index is cubed. So you're thinking, what times itself 3 times will get me -27? So what times itself 3 times will get me -27? So put in your final answer now in the chat. Final answers. What times itself 3 times will get me that -20? There we go. All right, you guys are picking the right one. Yep, yep. Good. Final answer. The reason why it's not I is because remember, I is the square root of 1, not the cube root. All right, so watch out for that index. Good job, guys. All right, so final answer, -3. Good. All right. Let's see if this last one trips you up a little bit. Negative cube root, -27. Okay, put your answer in for this one in the chat. Ooh, you guys are good. Yes. Yep. 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 Good. Nice. Yep. You guys got it. You guys got it. Nicely done. All right. So yeah, don't be intimidated by like all the stuff happening. Break it down. This one you knew from number 21 was -3. So you just tacked on another negative to get you +3. Perfect. Good job, guys. All right. Let me go ahead and I'm going to need to rush through a little bit towards the end here. So if y'all can just ask me any questions, if you need me to slow down, let me know, okay? All right, hopefully you guys know that this one is 2, if you were to break down that 8. This one, if we were to break down, I got 1, 2, 3, 5s, so that becomes -5. Here, -8, remember, not an I anymore. This is just -2, all right? And then the a to the 6th power, remember, divide the exponent. So this is a square. I don't need absolute values. I don't even need to check because the index is odd. So I don't even need to worry about absolute values when the index is odd. Okay? This one, this is just gonna be negative, all right? And then divide the exponent, so b to the 4th. Negative b to the 4th. All right. And then 27, I'll show this one. All right, starting with the -32. All right, the negative, I'm just gonna go ahead and because it's odd, all right, I just know my final answer is gonna be negative. 32, I could break that down to be 4 times 8, 2, 2, and this is 2, 2, 2. So that's 5 2s. I can take out a 2. Divide the exponent, and I just get x to the 1st power. divide the exponent, and I get y to the second power. Don't need to think about absolute values because again, the index is odd. All right, and the last two. So I have something to the 6th power, so I'll divide the exponent. So this is 5a squared b to the 2nd power. All right, and then I get 25a to the 4th b to the 2nd. All right, and the last one. Go ahead and I'll let you guys put your answer in the chat for that last one. Ooh, good one. Yep. Yep. 2 for 2. Good. 3 for 3. Nice. 4 for 4. Good job, guys. 5 for 5. Good. I got 5 right answers. 6 right answers. See if we can get one more. Yes, good job. All right. Yep, final answer, 3y plus 5. No absolute value needed. Good. So remember, divide the exponent, and that just gets you 3y plus 5 to the 1st power, which simplifies just to 3y plus 5. Great job, guys. You did awesome. Okay, so let me see if there's any questions in the chat, and then you guys can practice with homework.